Wait. Hello, everyone. Okay, this video is a remake video for the example 10.6. Okay, and the reason I want to remake this video because I want to clear some sign convention issue in torsional load. Okay, so let's look at the example 10.6. Okay, example 10.6 is also an angle twist calculation problem. Okay, so for the angle twist calculation, okay, so don't forget when angle twist calculation, what's the formula? The formula angle twist in torsional node is equal to TL over GJ. Okay, T is the torque. Okay, L is the length. Okay, G is the shear modulus, and J is the polar moment of inertia. Okay, so he say, okay, let's look at problem. Let's say the shaft. Okay, the shaft here, the shaft is subject to multiple load. Sorry, multiple torque. Okay, so torque at A, torque at C, and torque at D. Okay, and okay, it says determine the displacement of the tooth P on gear A. Tooth P on gear A. Okay, so actually, so I don't want to make a I don't want to make the question is too complicated. Okay, so let's replace problem. Okay, let's try to find the angle of twist of A with relative to E. Okay, and then okay, that's it. Okay. Okay, so we will calculate the angle of twist of A with relative to E. Okay, so in the previous example we say, okay, if your shaft is subject to multiple torsional load, this torsional load will create some this torsional load will create the internal will generate the internal torque, and this internal torque, for example, here and here and here, there will be an internal torque like T. This is TAC. Okay, let's ignore B. Okay, the internal torque TAC will internal torque TCD. The internal torque as the at the TDE. Okay, this internal torque will cause the deformation or angle of twist. Okay, and this torque also causes the local deformation in AC section, in CD section, and DE section. Okay, this internal torque causes local deformation on the AC section, CD section, and DE section. So it's cause local deformation because in this course, the material we are analyzing is all very hard material, strong material. So the torque only causes local deformation. Okay, and that's why we can use the cut section method to analyze each section and calculate the torque on each section and calculate the deformation on each section. Okay, because our material is very hard. Okay, each part is independent to each other. Okay, that's a good thing. Let's make life easier. Okay, so when we want to calculate the angle of twist of A with relative to E, what do we need? Okay, we need AE. We need AC plus 5CD plus 5DE plus 5D 5D 5DE. Okay, so we want to calculate local deformation, AC section, CD section, and DE section. So that's why we need we also need the value of TAC, TCD, and TDE. Yep, and then we can get the 5AC, 5CD, 5DE. Okay, so how to obtain the TAC, TCD, and TDE? Yeah, that's what the trick we often use in this course is called cut section method. Okay, let me draw the cut section. Okay, here we can analyze from left to right. Okay, so here is cut section. Here is okay. Let me draw cut section here. Here and sorry, I make a space for maybe here. Okay, at the position A, we have a torque here. Okay, 150. Okay, and here we'll talk a position A, position C. Is position C. So that's A, C, and final 150, 280, and D. It's 40. Okay, so that's A, C, E. Okay, so we draw these three sections. Okay, each section we use cut these three sections and analyze each section. And when we do analyze it, we need the called rigid body equilibrium. Okay, so let's do the analysis on each section. Okay, so let's call it 1, call it 2, let's call it 3. Okay. Okay, in the first section, dimension t equal to 0. Okay, so the torque A here. Okay, sorry, I should also, sorry, I should also write this first. TAC, TCD, or TDE. Okay, so. Okay, so in the first section, okay, the torque is here. Okay, the torque is here. Okay, and what is sign for this torque? Okay, use the right hand rule. Okay, use the right hand rule. The torque is rotate in this direction. It's rotate in this direction. So use your right hand rule. It's point this direction. Okay, point this direction is inward to the surface. Right now our cut surface is here. So this direction is inward to the surface. So it's minus 150. And the TAAC, I assume, is rotate in this direction because rotated is this direction. The thumb direction, use your right hand rule. The thumb direction is here. Okay, it's point outward to the surface, so it's positive. So okay, so that's why I assume the TAC is rotating in this direction because it's positive. Okay, so plus TAC. Okay, and then it's equal to 0. Okay, that's the first section. Okay, and then you can obtain the TAC is equal to 150. Don't forget the unit. The unit is kilonewton times meter. Okay. Okay, the first and the second one is, okay, we already know the torque at A is minus, its sign is minus. Okay, what about the torque at C? It's rotating this direction, so you also use the right hand rule. Okay, it's rotated in this direction. It's some direction is here. Some direction is here, so it's point outward to the surface. Right now our surface is here. Our surface cut section is here, so it's outward to the surface. So the 280 is plus. And CD, I also assume is rotated in this direction. Use the right hand rule. So the thumb direction is here. Okay, so the TCD is always, we assume is positive. So what is TCD? The TCD is, I think is negative? Yeah, negative. Okay, kilonewton times the meter. Okay. Okay, right now the final one is section 3. Okay, the torque A negative, torque C positive, and torque E is negative or positive. Okay, right hand rule, you rotate it this direction, so it's point, so your thumb direction is here. The thumb direction is here. Okay, it's point outward to the surface, so it's positive. And plus TDE equal to 0. So TDE is, what's the value? Okay, be careful when you check, calculate this, minus 170 kilonewton times the meter. Okay, let me finish this direction. Okay. Okay, so we have the torque AC, torque CD, and torque DE. Okay, we have the this torque as this on the AC section, CD section, and DE section. And then we can plug in all the information we have. Okay, so For this problem, it gives us the G is the shear modulus. The shear modulus is 80 gigapascal. So it's 10 to the power 9 par. Okay. So and what else for the J? Okay, what's the cross section area? We will only consider as the cross section of this shaft. Okay, we just ignore this gear. Okay, just ignore the gear. We only consider the shaft. Okay. Okay, say the shaft has the diameter 40 millimeter. 40 millimeters. So the shaft, the cross section is circular. So what's the polar moment of inertia? The polar moment of inertia is so equal to pi over 32 and d power 4. So pi over 32, d is 14 times 10 to the power minus 3 and power 4. Okay. Okay. So let's put everything together. Okay, so let's write the final expression. Phi AC phi AC equal to what is it? TAC 150, and don't forget that we have a kilo here, so it's 10 to the power 3. And what's the length for the AB section? AC section. AC section is 0.4. Okay. And what is GJ? G is 80 times 10 to the power 9. What is J? J is pi over 32. 14 times 10 to the power minus 3 to the power 4. Okay, so yeah, try to learn to use the engineering calculator to calculate this value correct. Okay. Yeah, you need to practice using the engineering calculator. Okay, this really need practice. Okay, so this expression for AC. So AC. So what is CD? Okay, CD. Okay, the denominator is the same. Denominator is the same. The denominator is the same. The only difference is the numerator. Numerator, what is CD? Is minus 130. Don't forget the K, 10 to the power minus 3. And what's the LCD? Length of LCD? 0.3. Okay. So, and okay, that's everything I move this here. Okay, sure. What's the CDE? Okay, what is the DE by DE? Okay, it's on the same material, so the denominator, I think is the same. Denominator is always the same. This in this problem. Okay, what's the torque DE? Torque DE is 100, 170, and don't forget the 10 to the power 3. Okay, don't forget the K. And what's the length for the DE? Length DE is 0.5. Okay. Okay, so when we want to when after you type in the engineering calculator, okay, you add these three together. Let me give you the value I have. The value should be okay. The AC is the AC. What is AC? AC. This color is not good. It's good. This color is not good. Okay, let's use the green one. Okay, AC, the value I have is, let me check, is 0.198939. 0.198939. Okay, what's the ACD? The CD is minus 0.129310. And what's the DE? DE is minus 0.28183. Okay, you add these three values together, you can see the answer should be minus 0.2122. Okay, so this positive, okay, is not correct. Okay, correct answer is minus 0.2122. Okay, so okay, because that's what I said at the beginning of this video, in the previous video, or I had some sign convention issue, so that's why I remake this video to clear the sign convention issue. Okay, if you found this textbook, the correct answer is minus. There is a minus sign for the correct answer. Okay, okay. So okay, just finish. Stop the video here. Okay, see you in another video. Bye bye. Hope that.